I'm Emily. I'm a staff engineer at Intuit Mailchimp. That means I say it depends a lot. That's kind of my job. Mostly, I would rather be painting. I'm a big fan of this guy named Curtin. He's pretty cool. And one of my proudest engineering achievements is that I'm a contributor to the Enterprise FizzBuzz project, which is really taking like a comprehensive view about solving the important business issues of today. So if you get bored during my talk, you can go check out Enterprise FizzBuzz Edition. As a painter, these are some of my brushes. And I'm putting this picture up today because today, as we're talking about testing, I'm going to paint with a broad brush, not with the little ones. And actually, as a side note, as a little oil painting lesson for you all right here, right now, in order to maintain kind of a painterly aspect, you do want to paint with the biggest brush you can in order to kind of stay loose and be more painterly rather than trying to make it a photo. So I'm going to paint with a very broad brush and talk in some stereotypes and some generalities to which almost everything I say is going to have an exception to it. So the exception might be your organization, it might be your data scientist, but we're just talking in generalities. I'm assuming if you're here that you agree with me about the title of my talk, that ML testing is a garbage fire and it's rough and it's not good. And it's just tough. It's difficult. It's time consuming. It's really hard to get people to do it at all. Even if they do it, it's really hard to get them to do it correctly. And ultimately, our applications don't work, or maybe they work, but they're subtly off. It's just a rough go of it. So as testing is near and dear to my heart because, I'm a software engineer. This is the culture that I come from. This is the background of like building these components that are really stable. And, I learned about testing right off the bat with the auto grader kind of coming to get me in data structures and algorithms. It's really baked into the DNA of how I approach this ML space. And we as like ML engineering and ML ops types, we love to kind of blow off steam by criticizing data scientists for how they do or don't write their code. There's a lot of this kind of stuff out there if you go looking for it. But really, data scientists don't want to ship crap. We can get into this kind of antagonistic mindset of like, they're really just out here to make our jobs really difficult. And that's not true. They don't want to ship crap. So why do they keep shipping crap? Why does this keep happening? So that kind of brings me to the outline of this talk, which is that testing for ML applications is a technical problem, and it's a human problem. And based on that human problem, it's a different technical problem if you frame it right. So, technical problem. This is probabilistic, right? Especially when we're talking about core modeling. I'm not a data scientist. This is the kind of model I write. But ultimately, you're trying to test whether or not something is the correct answer when you're doing unit testing kind of operations. And that's really hard when your code is probabilistic. You're not always going to get the same thing back. So some technical approaches to that, talking about Python ecosystem in the context of like pytest or something like that. You have tools like Hypothesis. You have tools like Flaky. Hypothesis is a really, really good one that doesn't get a whole lot of airtime. It helps you throw a bunch of input data at your unit tests. It's kind of a decorator that you wrap around your functions, and you can build these text generators or numerical generators, and it'll generate all kinds of gobbledygook so that you don't have to sit there and think through all your edge cases. Also has some cool features where like if it fails on one specific value, it'll hang on to that value so that next time you run it, you hit that again, even though most of the time it's generating a little bit randomly. So Hypothesis, very cool, highly recommend. Flaky decorators, you wrap it in like @flaky and give it some definitions of like, if it fails, run it 3 more times, and if it passes one of those, good enough. So that's all great, like stuff that we can plug into pytest. Cool. That really doesn't get to the core of our problems, right? Because when we're talking about machine learning, we're dealing with these absolutely massive systems and a lot of hardware issues. It's a pet peeve of mine that we talk about these machine learning libraries, especially heavy ones like PyTorch and TensorFlow, as though they're portable, and they're just not. Especially if you're trying to do GPU integration, the requirements for these, the tertiary dependencies, the hardware specifications go really deep. So they're really not portable. You can't just throw them around in places. And then you get down to usability issues like, well, how do I plug in pytest to a notebook? That's not like the iteration cycle that this was built for. I mean, you can do it, but that's not what it was built for. So that kind of brings us to the fact that this, yeah, we can talk technical problems about testing probabilistic code, but really this whole ecosystem is more of a human problem. And people are talking about this human problem, to be sure. So this is from an interview study where if you collect people's opinions and format it in LaTeX, it becomes research. So just to read this quote directly, I used to see a lot of people complaining that model developers don't follow software engineering practices. At this point, I'm feeling more convinced that they don't follow software engineering practices, not because they're lazy, but because software engineering practices are contrary to the agility of analysis and exploration. That really rang true for me. Hopefully it rings true for you. So that if we kind of zoom back out, we have to ask the question, why do we test? So let's take this through each of the kind of the personas involved and answer that question piecewise. So as an engineer, we test because it's in our DNA, because solid bricks equals solid buildings, because the auto grader is going to come get you, because this is what you're supposed to do. This is how you ensure software quality. This is how we, make sure that we're not shipping garbage. This is why you test. Isn't that obvious? And then we throw it over to a data scientist who says, oh, well, we test because, results might look okay, but they might not be okay. And we do a lot of statistics to evaluate it. And, we're more worried about people criticizing our math. And it's a mindset shift. So they're still thinking about quality and testing, but it's coming from a different place. And then you throw it over to a C-suite type, and they're saying, we test because it's about business value. We test because outages matter to our customers, and we enforce this by just providing the right incentives to our direct reports. So it's not a solid answer about why do we test? And as engineering types, zooming out and thinking about the perspectives of others kind of puts a different cast on it. And that kind of reframing brings us into a place where this is a different technical problem. We get really hung up on unit testing and kind of, we got to run pytest and we got to have checks and CI and we got to have this very specific software engineering driven cycle. And I would argue that we are confusing the means with the purpose. If we get stuck on testing in a software engineering specific definition, we are missing the forest for the trees. So I want to talk about some other ways that we can pursue quality and good testing besides that kind of very rigid software engineering perspective. So we can talk about data reliability engineering, different environments, observability, and where unit testing still has a place. So data reliability engineering, this is a place where we are taking the principles of SRE, site reliability engineering, and applying them to the data space. There was a really excellent talk on this last year by Igor from Big Eye that I highly recommend you go look up. So these principles of SRE are stuff like embracing risk, monitoring everything, using automation, and data reliability engineering is about taking those principles and applying it to our data streams. So by embracing risk, we say, this is a crazy, crazy kind of pipeline that we work with. Data processing has a lot more to do with like mineral processing than it does with web development, because you're going to get some ore into your mineral processing and it's going to have different percentages of the thing you're looking for. And somebody already said this morning, garbage in, garbage out. So by applying data reliability engineering practices, we are putting data in its proper place of staying suspicious of it. Further, we're also putting data in the proper place that we all talk about all the time. So how many of you have heard, oh, data scientists spend the majority of their time doing data cleaning? Have you heard that? I've heard that 100,000 times. But we don't act like it when it comes to testing. When it comes to testing, we talk about code and we talk about functions and all this. We're not talking about the input and the output data, which is what this whole deal is all about. So I've been really encouraged to see more people talking about this, about bringing in these frameworks and really putting data in the center of our operations rather than our code. For pre-prod environments, this is perhaps a little specific to the environment that I'm working in at Intuit Mailchimp. Perhaps this applies to you. But we have this issue where because these environments to run these models are so specific, it's really, really hard, even in these days of, Docker and all this stuff that was supposed to solve the it works on my machine problem, we still get to, oh, but it worked in dev. Or, well, in order to really see how that's going to go, you got to run that in prod. You got to test in prod. Production is the industry term for that. You can take that with you. So what I would argue for is really leaning into the idea of pre-production environments. You might call this staging, you might call it pre-prod, but essentially embracing the idea that for these end-to-end pipelines, it is a waste of time to try to build really intricate mocking mechanisms for each of these different systems involved. And it's way more useful to our customers, data scientists, and to us as people who are looking at the business to just build a prod-like environment that's contained and that's not being shipped out. So that way we can inspect each part of this system and put some automation around it that's prod-like, and the same kind of automation that we're going to put in prod when it really matters. The environmental issue is, I don't know, something I've run up against a whole lot, and maybe y'all have too, about, managing, well, we do our development locally on, M1 Max on Docker containers that have to do this weird loading, and then the containers end up being built on, ARM 64 instructions, and you try to ship it up to GCP, and now it's on x86 instructions, and it doesn't work. And now we got to go test it in prod because of all this stuff. So it's a much bigger and much more like fundamental infrastructure issue that I've come across. It's like, how do we actually provide these safe environments? This comes down to how you manage your project instances and cloud providers. How do you manage environment variables that might have a little subtle switching between dev and stage and prod? These kind of come down to operational issues, right? This is like DevOps stuff. But it's really important in order to empower our data scientists to really see what is happening. And speaking of seeing what is happening, ML observability. And y'all have heard a lot of stuff about this. I'm not going to go deep into it, but just this is acknowledging the fact that models can fail in ways that don't necessarily show up as failures. This is drift detection. This is, again, thinking about all of this machine learning and data processing like manufacturing, where you've got junk that's coming in. You have to evaluate it as it's coming in. ML observability paired with data reliability engineering really pushes you towards that just like holistic systemic evaluation. Another one that I want to talk about is the production readiness score. So this is a business concept. This is taking how we talk about models and kind of flipping it a little bit to say, these models are business assets. Unless you're in academia, and then they're research assets, but I'm coming from a business perspective. So these are business assets. We spend a lot of time and a lot of effort pouring energy into building these models, and we need to treat them like they've had a lot of energy and time and effort poured into them. We need to invest in them, and we need to treat them like the assets that they are. One way of doing that is the production readiness score. So this is an acknowledgement that stuff that goes to production, especially in this modeling area, just because it's in prod doesn't mean it's ready for prod. Especially, and that might be because we have some models that are internal and they have laxer standards, or, there's all kinds of reasons for that. So when you do a production readiness score, there's lots of different ways you could do this, but this is about evaluating kind of those human elements of what's going on here. So your score goes up if you have documentation. Your score goes up if you have ML observability set up. Your score goes up for governance, and even I've seen ethical compliance. So you can do this kind of as a numerical grade. I've also seen this done very effectively as like a stoplight system. So you might have 3 major categories like code quality, documentation quality, and governance compliance. And you get like a red light, yellow light, green light for each of those, which can be a little bit more intuitive than trying to be hyper specific about like a number and have, whenever you put a number to something, they're data scientists, they're going to optimize the function, right? So find the lowest effort path to get the number to go up. So, red light, green light, yellow light, that can be a little bit more intuitive. As a hot take coming live from me, I think data scientists should be on call. Because we're talking about this whole testing thing, we're talking about enforcing quality, right? So it's weird that in this ecosystem we, again, not every business, not every data science department, but a lot of businesses and a lot of data science departments, you have like the data scientists writing the code and the other people who are on call for it. And that is a recipe for mismatched incentives. Because if you're writing it and you're not experiencing the pain of when it goes wrong, then you don't have an incentive to build on that. You also don't have an incentive if it's not coming down from on high. None of what I'm talking about matters if your C-suite is not invested in quality for data science. If they're invested in velocity and not quality, good luck with any of this. Seriously, these are human problems. We can talk about pytest and all that, but it is incentives top to bottom that really make a difference for getting good stuff out the door. So ultimately, velocity comes from good tools. And a lot of what we're talking about at this conference is some good tools. But quality comes from good incentives. So you can't tool your way out of that. You can, something like a production readiness score dashboard gives you a communication tool to try to get to those incentives, but you've got to have incentives that come down from on high. So it kind of gets us to this place of talking about all those corporate values. And, I went to art school before I was in technology, and I'm just very suspicious of all these corporate values. they just feel like putting a shiny, they feel purposeless. They feel like you're putting a shiny wrapper on stuff. But like, no, seriously, I'm kind of talking about some corporate value stuff right here, like collaboration. So we get to better ML reliability through understanding data scientists as our customer, through kind of customer obsession. We get there by prioritizing their needs over our software engineering dogma and finding ways to work together. We get there by focusing on bigger picture inputs and outputs through data reliability engineering, through ML observability, all that stuff, and aligning our incentives top to bottom. So I kind of put this talk together and then was like, oh gosh, that's like corporate value stuff, isn't it? But it's like, it's kind of true. So it looks like I might be the only talk this morning that's going under time instead of overtime. We're kind of reaching towards the end here, which is good. We're all headed to lunch. So kind of wrapping up here, we extinguish the garbage fire of ML testing, or at least reduce it to more of a burning smolder by not focusing on testing, by reorienting our thinking into something that's bigger picture, and by making really dumb memes about it. So that's what I got for you today. Thank you for sticking with me through a testing talk.